Hi everyone, welcome to my channel. I'm Sharon JC Salon, and today's topic is all about polar coordinates. If you ever wondered what they are, how to plot them, or how to convert them to and from rectangular form, you're in the right place. Let's make this as simple as fun as possible. So get your notebook and get ready. Let's go! What is polar coordinates? In math, we use the Cartesian or rectangular coordinate system, where we plot points as x and y, but sometimes it's easier to use polar coordinates, especially for circular or spiral shapes. A polar coordinate is written as r and theta. Here's what that means. R is the distance from origin, the center like the middle of a target. Theta is the angle usually measured in degrees or radian, starting from the positive x-axis. So instead of going right and up like x and y, we go out and turn. Think of a radar screen or as spinning a clock hand. That's a polar coordinates.
Plotting polar coordinates, you have to start at the origin, then rotate angle theta from x-axis, and lastly, move our units outward in the direction. Plotting polar coordinates, you have to start at the origin, then rotate angle theta from x-axis, and lastly, move our units outward in the direction.
Plotting points in polar coordinates. Plot the points whose polar coordinates are given. First, 1 and 3 pi over 4. Second, 3 and negative pi over 6. Let's start with point 1 and 3 pi over 4. Here, r is equal to 1 and theta is equal to 3 pi over 4. Now, 3 pi over 4 is an angle in a second quadrant and it's equal to 135 degrees. So we start from the origin, then rotate 135 degrees counterclockwise, and lastly move 1 unit in that direction. And now we have this. Next is point 3 and negative pi over 6. This time, theta is negative, which means we rotate clockwise. Negative pi over 6 equals to negative 30 degrees. So we rotate 30 degrees clockwise, then move 3 units forward from the origin in the direction. And now we have this.
And now, let's proceed to polar to rectangular coordinates. Sometimes we need to switch between the polar and rectangular system. To convert from polar to rectangular, we use trigonometry, where x is equal to r times cosine theta, y is equal to r times sine theta. This formula comes from a right triangle where x and y are the legs and r is the hypotenuse.
For example number 1, we have 4 and pi over 6. And for our example number 2, we also have here the 6 and 2 pi over 3. First, we have to solve for x, which is the cosine, and y for the sine. So x is equal to 4 cosine pi over 6. We copy 4. Then cosine pi over 6 is equal to square root of 3 over 3. Then 4 times square root of 3 over 3 is equal to 2 over square root of 2. And now for y, we have 4 sine pi over 6. 4, copy the 4, then sine pi over 6 is 1 half. So 4 times 1 half is equal to 2. Then for our answer is 2 square root of 2 and 2. For our second example, same process, x is equal to 6 cosine 2 pi over 3. So copy the 6. Then Cosine pi over 2 pi over 3 is equal to negative 1 half. Then 6 times negative 1 half is equal to negative 3. For our y, 6 sine 2 pi over 3, then copy the 6 sine 2 pi over 3 is equal to square root of 3 over 2. Then 6 times square root of 3 over 2 is equal to 3 square root of 2. And our two answers is first the negative 3, then second the 3 and square root of 2.
And now, let's move to rectangular to polar coordinates. Now, let's go to the other way, from x and y to r and theta. Here's are the formulas. R equals square root of x squared plus y squared. This gives you the distance from the origin. Theta is equal to arc tangent y over x. This gives you the angle.
For our first example, we have negative 1 and 1. For our second example, we have here the 3 square root of 3 and negative 3. And now let's solve for number 1. We have r square root of negative 1 squared plus 1 squared. So square root of negative 1 squared is 1 plus 1. So we have square root of 2. Now let's proceed to theta. Arc tangent 1 is to negative 1. Then we have arc tangent 1 times negative 1 is equal to 3 pi over 4. And now we have the two answers, which is our first answer is square root of 2. Our second answer is 3 pi over 4. If you want to solve for number 2, you can pause the video and try to solve it for your own. Let's proceed to number 2. R is equal to square root of 3 square root of 3 squared plus negative 3 squared. R is equal to square root of, you have to do the right first, plus, so negative 3 squared is equal to 9. Then 3 square root of 3 squared is equal to 27. So we have to add these two. Is 36. So square root of 36 is 6. And now let's go to beta equals arc tangent negative 1 over square root of 3. Negative pi over 6 means to beta equals 11 pi over 6. So now we have the two answer for number 2. First answer is 6. The second one is 11 pi over 6.
And now, let's go to the relationship between polar and rectangular. You might be wondering why I learn both, because they help describe the same point or object in different ways. Rectangular coordinates are better for straight line motion, while polar coordinates are better for circular and rotational motion. Think of a drone. If it is flying in a spiral, polar coordinates are perfect. And now, let's proceed to converting rectangular equation to polar. When converting equation, just substitute this. First, x is equal to r times cosine theta. Second, y is equal to r times sine theta. And lastly, x squared plus y squared equals r squared. This changes rectangular equation to polar ones.
For our first example, we have here x squared plus y squared is equal to 9. And for our second example, we also have here, for our number 2, we have y squared equals to 4x r squared is equal to 9. Then r squared is equal to 9. The square root of r squared, the square root of 9 cancel, becomes r equal to square root of 9 is 3. r sine theta squared is equal to 4 r cosine theta. r squared sine squared theta is equal to 4 r cosine theta. r is equal to 4 cosine
Theta over sine squared theta.
Now, let's move to converting polar equations to rectangular. Now, let's reverse it. Convert from polar to rectangular. Take the polar equation and use the same substitutions. First, r is equal to square root of x squared plus y squared. Second, cosine theta is equal to x over r. And lastly, sine theta is equal to y over r.
First is r is equal to 2 plus 2 cosine theta, and r squared is equal to 2r plus 2r cosine theta. Then we have here the x squared plus y squared is equal to 2r plus 2x. Then x squared plus y squared is equal minus 2x equals 2r. Then we have x squared plus y squared minus 2x squared is equal to 4r squared. Now let's do x squared plus y squared is minus 2x squared equals 4x squared plus y squared. For our second example, we have here r is equal to 2 sine
theta, r squared is equal to 2r sine theta, and x squared is plus y squared is equal to 2y, x squared plus y squared is minus 2y is equal to 0. Then x squared plus y minus 2 1 squared is equal to 1.
And that's a wrap for today's lesson. You've learned how to plot polar coordinates, convert between polar and rectangular points, understand the relationship, and change the entire equation between the two systems. If you found this helpful, please give the video a like and drop a comment if you have a question. And lastly, subscribe for